Today I want to talk about relational operators. They're used to compare numeric and character values to determine relative order. We have different relational operators like greater than, less than, greater equal, less equal, and equal equal. So in this example here, we're using these relational operators. For example, if you want to compare to see if 12 is greater than 5, you can use greater than. 12 greater than 5 is true. 7 less equal to 5 is false. If x is 10, x equal to 10 is true. X less equal 8 is false. You can see that we can use these relational operators to compare two different values. The result of these relational operators are Boolean. It means they're either true or false. We can say the value can be assigned to a variable. When you say bool result equal to x less equal to y, you're comparing x and y. If the result of x less equal to y is true, result becomes true. It will assign 0 for false, 1 for true. So when you have a Boolean operator, whatever you have here, they will get compared together. The result will be either true or false. When you have true, the computer will store 1 in memory. When you have false, the computer will store 0. Do not confuse equal and equal. They're different. Equal is used for assignment. Equal is used for comparing two different values. This is a hierarchy of relational operators. You can see that the precedence of the greater equal, less equal is the highest. After that, we have equal, and not equal, which they have the lowest precedence. We can use this when we evaluate an expression that contains multiple relational operators. If you have an expression that has several of these together, the first one that will happen is the one that has the highest precedence. So we have if a statement in C++ that supports the use of this decision structure. With if statements, you can check a condition to see if that condition is true or false. It allows the statements to be conditionally executed or skipped over. It models the way we evaluate real-life situations. For example, if it's cold outside, you wear a coat and you wear a hat. If you look at this sentence here, if outside is cold, you will wear a coat and then you will wear a hat. If the outside is not cold, then you will not wear coat and a hat. This is the structure of the if statement in C++. We say if condition, then we have some statements. If the condition is true, the statements run. If the condition is not true, the statements are not going to run. There is no semicolon after the closing parenthesis. After each statement, there is a semicolon. We see the block of the statements inside the braces is what we call the body of if statement. If there is only one statement in the body, the open and close braces, they may be omitted. So in C++, you can use this syntax to write if statements. If this condition is true, these statements, they run. If this condition becomes false, these statements, they don't run. We say if the condition is true, the statements in the body are executed. If the condition is false, the statements are skipped. This flow of control shows how this if condition works. If this condition is true, the statements run. Otherwise, they are skipped. In this example, we say if score is greater or equal to 60, you passed. If this condition becomes true, it means if the score is either equal to 60 or greater than 60, it will display you passed. In this example, if the score is greater or equal to 90, grade becomes A and it will display wonderful job. If you have only one statement, you don't need to have braces. If you have more than one statement, then you will open a brace and then you will close a brace. We say if as a keyword, it must be lowercase. Condition must be an open and close parentheses. Do not place semicolon after condition. Do not forget the open and close braces around a multi-statement body. Do not confuse equal with equal equal. We have some recommendations for if statement style. We place each statement on separate line after condition. We indent each statement in the body. When using open and close braces around the body, we put an open and close on lines by themselves. We say an expression whose value is 0 is considered to be false. An expression whose value is non-zero is considered true. An expression need not to be comparison. It only can be a single variable in mathematical expression. Whenever you have something, some expression that gets evaluated to something other than 0, that is true. If you have an expression that will get evaluated to 0, that expression is false. In C++, we say a flag is a variable that signals a condition. It is usually implemented as a bool. For example, true means the condition exists. False means the condition does not exist. The flag value can be both set and tested with if statements. In this example here, we have a flag, which is valid months, which is a Boolean flag, and it's true. We say if months less than 0, valid months equal to false. If valid months monthly payment equal to total divided by months. If this condition is true, valid months becomes false. If the valid months is true, the monthly payment becomes total divided by months. When we talk about flags, we can have integer flags. We say we can use integer variables as flags. Remember that the 0 means false and any other value means true. For example, I can say int all equal to 0. This will set to false. If a count greater than max students, all equal to 1. This condition will get checked. If the condition is true, all done becomes 1. We say if all done cout tasks finished. If this all done is true, it will display task finished. If this is false, it will not display anything. This is what we call a flag. The flags are used when you have something that it may or may not happen. It means it's either true or false. We could use a Boolean flag or we could use an integer flag. This is the general syntax for if statement. You can see in this example, we say if conditioned, we have a statement set 1, else a statement set 2. If the condition is true, the statement set 1 runs. Else, if the condition is false, the statement set 2 runs. Depending on the condition, either statement 1 runs or statement 2. We say if the condition is true, a statement set 1 is executed and statement set 2 is skipped. If condition is false, the statement set 1 is skipped and statement set 2 is executed. This is the flow of control. If this condition is true, the statement 1 runs. If this condition becomes false, the statement 2 runs. This is an example of an if-else statement. If score is greater or equal to 60, you passed. Else you did not pass. If this condition is true, you pass. If this condition is false, you did not pass. If int rate is greater than 0, interest is low amount times int rate. We display the interest. If this condition is true, these statements runs. If this condition becomes false, it will display you owe no interest. So the general syntax for if-else statement is that if this condition is true, the statement runs. If this condition becomes false, the else statement runs. If you have more than one statement, you put them in open and close braces. If there are two conditions and both of them can be true or both can be false, then use two if statements. In this example, we say if num is greater than 0, cout num is positive. If num modulus 2 equal to 0, cout num is even. If this condition is true, It will display the num is positive. If this other condition is true, it will display num as even. We have two different conditions that they get checked. If the two conditions cannot both be true, then a single if-else statement can run. If num modulus 2 is equal to 0, we display the num as even. If num modulus 2 is not equal to 0, we display num as odd. If this condition is true, this happens. If this condition is false, the other statement happens. So sometimes you want to check several conditions, then you can use several if statements. Sometimes you want to check one single condition to see if it's true or false. Then you can use if-else statement. You could compare with floating point numbers. It is difficult to test for equality when working with floating point numbers. It is better to use greater than or less than test to see if the value is very. When you want to compare to a floating point number, it's not easy. The best way is to try to see if you're getting near to 0 or not. If you want to compare to integers, it's easy because you can just use equal. But when you want to compare with a floating point number, you could find a difference between them to see if that is a very small number, which we call it epsilon or not. You can have if, else, if statements in C++. This is a chain of if statements that test in order until one is found to be true. If it's raining, take an umbrella. Else, if it's windy, take a hat. Else, if it's sunny, take sunglasses. If this condition is true, this statement runs. Else, if the other condition is true, the other statement runs. So in this example, you see how if, else, if works. If the condition 1 is true, statement 1 runs. If the condition 1 is false, but condition 2 is true, statement 2 runs. If all of those conditions are false, none of them run. We can use a trailing else. Is used with a set of if, else, if statement. It provides a default statement or action that is performed when none of the conditions is true. It can be used to catch invalid values or handle other exception situations. In this example, if the age is greater or equal to 21, it will display adult. If the age is not greater or equal to 21, but age is greater or equal to 13, it will display teen. If the age is not greater or equal to 21 and age is not greater or equal to 13, but age is greater or equal to 2, it will display child. If all of these conditions become false, it will display baby. This is a trailing else. It means it will check the conditions one by one. If all of the conditions are false, it will go to the else statements. If any of those conditions are true, the cout statement for that statement runs. You could create menus in C++, which are a list of choices presented to the user on the computer screen. You could use if-else statements to create menus. We say the menu-driven program is a program execution is controlled by users selecting from a list of actions. A menu-driven program can be written using if, else, if statements. You could organize a menu-driven program. You can display a list of numbered or lettered choices for actions. You can input users a selection of number or letter. You could test the user selection and condition. If a match, then execute code to carry out desired action. If not, then test with the next condition. You can check different conditions to see if they're true. If the condition first is true, then you can have a statement that runs, and then you can use that to create a menu. We say an if statement that is part of the if or else part of another if statement is what we call a nested if statement. This can be used to evaluate more than one data item or to test more than one condition. In this example, if the score is less than 100 and if the score is greater than 90, the grade becomes A. If both conditions are true, the grade becomes A. If you want to check several conditions, you can use nested if statements. It means when you have if statements inside if statements. So in this example, I have an if statement. We say an else matches the nearest previous if that does not have an else. We say if score is less than 100, if score is greater than 90, grade becomes A. If both of those conditions are true, the grade becomes A. This else statement goes with the second if, not the first one. Because the way that the else they work, they get matched with the nearest if statement. They get coupled with the nearest if statement. We should use proper indentation that helps, that aids understanding how the code works. We have some logical operators like and, or, and not. The and becomes true when both of them are true. The or becomes true when one of them are true. The not becomes true when it's false. We can say the and is the new relational expression is true if both expressions are true. And the new relational expression is true if either expression is true. Not reverses the value of an expression. True expression becomes false. False expression becomes true. These are the logical operators that you have in C++. In this example, we have x, which is 12. We have y, which is 5. We have z minus 4. X greater than y and y greater than z is true. Because 12 is greater than 5 and 5 is greater than minus 4. And become true when both of them are true. X greater than y, 12 is greater than 5. And minus 4 is greater than 5. Both of them are true. Z is minus 4. Minus 4 is not greater than 5. This is false. Since one of them is false, false and anything is false, this will give you false. X less equal to z or y equal to z is false. If you look at x, x is 12. Z is minus 4. 12 less equal to minus 4 is false. Y equal to z, 5 is not equal is false. False or false is false. X less equal to z or y not equal to z is true. Because z is minus 4. X is 12. 12 is not smaller than minus 4. This is false. Y not equal to z, y is 5. Z is minus 4. This is true. True or false is true. So x is 12. 12 greater equal to minus 4 is true. Not true is false. So we could use logical operators in bool variables. When you say bool done equal to false, if not done and count less than 6, if done is false, not done becomes true. Since this is true and count is less than 6, the statements run. In this example here, if the done becomes true, not true becomes false, and this becomes false. The way that you can stop this if a statement is by making and changing the done to true, because not true is false. If you want to use an expression that keeps going until the done becomes true and then it stops, you can use a condition like this. Because as soon as this becomes true, not true is false, and false and anything is false, and it stops. We have short circuit evaluation. We say if an expression using the AND operator is being evaluated and the sub-expression on the left side is false, then there is no reason to evaluate the sub-expression on the right side. If you have A and B, one of them on the left side, A is false. It doesn't matter what is B, because in any situations, the result will be false. If an expression using the OR operator is being evaluated and the sub-expression on the left side is true, then there is no reason to evaluate the sub-expression on the right side. It is skipped. When you have A or B, if A is true, it doesn't matter what is B, because true or anything is true. We call this a short circuit evaluation. We have some logical precedence, and logical operators. The not has the highest order of precedence. Then we have and then we have or. You can see the highest order of precedences with not, then and or. For example, 2 less than 3 or 5 greater than 6 and 7 greater than 8. 5 greater than 6. You can see we have and or here. The parenthesis has the highest order of operation. After the parenthesis, we have and or. The and is higher than or. 7 less than 8 is false. 6 less than 5 is false. False and false is false. 3 greater than 2 is true. True or false is true. You can see it's true because and is evaluated before, or first and gets evaluated and then or. We have different operators, they have different precedence. The highest order of operations is with arithmetic operators. Then we have relational operators and then logical operators. In this example, 8 less than 2 plus 7 or 5 equal to 6 is true. 2 plus 7 is 9. 5 equal to 6 is false. False or true, we have 2 plus 7 greater than 8. The whole expression becomes true. 2 plus 7, 7 and 2 is 9. 9 is greater than 8. That is true. True or false, which 5 equal to 6 is false, it will be true. Because true or anything is true. So when you have several operators together, the arithmetic operators, they get evaluated first, and then relational operators, and lastly, logical operators. We could check numeric ranges with logical operators that are used to test if a value is within a range. We say if grade is greater equal to 0 and grade is less equal to 100, see out valid grade. If you want to check to see a grade is a specific range, you can use AND, which is ampersand ampersand. You can also test if a value lies outside of the range. If grade is less equal to 0 or grade is greater equal to 100, see out invalid grade. You cannot use mathematical notations. You could not say if grade greater equals 0 less equal to 100. This doesn't work. If you want to compare to see if something is between something, then you need to use AND. If you want to see if a variable is not in a range, then you can use OR. You could validate user input. Input validation is inspecting input data to determine if it's acceptable or not. You want to avoid accepting bad input, you can perform various tests using range, reasonableness, valid menu choice, zero division. You could validate the data to see if it's the range or not. In this example, you're validating the grade to see is it between 0 to 100 or not. In the second example, you're validating it to check if it's not in between 0 to 100. When we have a variable, you have a scope, which we say the scope of a variable is the block of which the statement is defined, from point of definition to end of the block. Variables are usually defined at the beginning of a function. They may instead be defined close to the place where used. The scope of the variable, it means where the variables are visible, where they're defined, where you can see them. We have different kinds of scopes. Variables defined inside open and closed braces, they have local or block scope. When in a block that is nested inside another block, you can define variables with the same name as the outer block. When the program is executing in the inner block, the outer definition is not available. So when you define variables, you will have scope. A scope means where the variable is visible. You could have local scope and you can have global scope. Local scope means when a variable is defined inside a function and it's only accessible there in that specific scope. When you define a variable on top of your program, it becomes global. Means it can be visible everywhere in the program. Everywhere it's available to use. It's not a good practice to use global variables. Try to use local variables as much as you can. You can use characters and strings. You can use relational operators with characters and strings. You can check to see if the menu choices equal to A. You can check to see if the name 1 is greater equal to name 2. When you compare characters, you're comparing the ASCII values of characters. When you compare string objects, you're comparing the ASCII values of the characters and the strings. The comparison is character by character, starting with the first character of each string. You cannot compare C-style strings with relational operators. So when you compare two different strings, you are comparing them character by character. If all of the characters are the same, those strings are the same. If there is any difference in one of the characters, those strings are not equal. We have some functions that require the CC type header form, like is alpha, is AL num, is digit, and is lore. Is alpha becomes true if argument is letter, false otherwise. Is AL num becomes true if the argument is letter or digit, false otherwise. Is digit becomes true if the argument is a digit between 0 to 9, false otherwise. Is lower becomes true if the argument is a lowercase letter, false otherwise. Is print will be true if the argument is a printable character, false otherwise. Is punct becomes true if the argument is a punctuation character, false otherwise. You can check to see if it's uppercase or space. Is upper becomes true if the argument is uppercase, lower, false otherwise. Is space becomes true if the argument is the white space character, false otherwise. With these functions, you can check an argument. These functions are defined in the CC type. They will give you either true or false. If you want to check to see an argument is uppercase, lowercase, it's a digit, it's a number, you could use these functions which are defined in CC type. We could use the conditional operator. It can be used to create short if-else statement. For example, expression, question mark, expression. If x is less than 0, y becomes 10. If x is not less than 0, z becomes 20. The first expression is the condition to be tested. X will get tested to see it's less than 0 or not. If it's less than the 0, then the second expression executes. The third expression executes if the condition is false. So this is what we call a Turner operator. The Turner operator is a different way of writing if-else statements. If this condition is true, this statement runs. If this condition is false, the other statement runs. You could use a conditional expression. In this example, I say num is equal to 13. I have a string result, which is num modulus 2. I say result becomes num modulus 2 equal to 0. If you divide num by 2 and the result is 0, the result becomes even, otherwise becomes odd. I display num is result. It will be either even or odd. When you divide a number by 0, if the remainder is 0, the result becomes even, otherwise becomes odd. This is what we call a Turner operator. We could use a switch statement in C++. It uses the value of an integer expression to determine the statement to execute. It may sometimes be used instead of if, else, if statements. This is the general syntax for switch. We say switch int expression, case expression 1, expression 2. The value of this int expression will get compared with all of these cases. If it's equal to one of them, the statement set for that case runs. If it's not equal to any of them, it will go to the default. We say int expression must be an integer, variable, or a character, or an expression that evaluates to an integer value. Expression 1 to expression n must be constant integer type expression and must be unique in the switch statements. Default is optional but recommended. So what you put here, it can be an integer, it can be an expression that gets evaluated to integer. It can be a character. We say if the expression is evaluated. If the value of an expression is compared against expression 1 to expression n. If nth expression matches value expression I, the program branches to the statements following expression I and continues to the end of the switch. If no matching value is found, the program branches to the statement after default. We have a break statement that is used to stop execution in current block. It is used to exit a switch statement. It is used to execute a single case statement without executing a statements following it. With break, you can break a loop. You can also break a switch. In this example, I'm switching on the gender. If gender is equal to F, it will display female. This break will stop that case. If the gender is equal to M, it will display male. Break will stop that case. If the gender is not F and is not M, it will go to the default. It will display invalid gender. The break is used to stop a case. We say a switch statement is a natural choice for a menu-driven program. With switch statements, you can easily create menu-driven programs. You can display a menu, you can get the user input, you can use user input as enter expression and switch. You can use many choices as expression against case statements. We have also enumerated data types in C++, which is a data type created by program. It contains a set of named integer constants. For example, I can say enum, fruit, apple, grape, and orange. Or I can say enum days, month, Tuesday, Wednesday, Thursday, and Friday. When you have a data type that it can be some specific themes, you can use enum. Enumerator means a variable that can be only these. How you can define an enumerator data type using enum? If you say fruit snack, you're creating an enum variable. To define variables, we use the enumerated data type. If you say days, workday, and vacation day, you're defining two different enumerated variables from days. We say a variable may contain any valid value for the data type. If you say snack equal to orange without quotes, the snack becomes orange. The snack is a fruit. Fruit can be either apple, orange, or grape. When you say if workday equal to Wednesday, you're comparing the workday with the Wednesday. If you look at the workday can be either Monday, Tuesday, Wednesday, Thursday, or Friday. You could use comparison of enumerated data types. Enumerated data type values are associated with integers starting at 0. When you say enum, fruit, apple, grape, and orange, there's a number associated with each one of these, which the number for the apple is 0, for the grape is 1, and orange is 2. You can override the default association. You can say enum, fruit, apple equal to 2, grape equal to 4, orange equal to 5. You can override these associated numbers. Enumerated data type values can be compared using the integer values. You can say if a snack equal to 1. Enumerated data values cannot be assigned using their integer value. You couldn't say snack equal to 2. Enumerated data types improve the readability of program. Enumerated variables cannot be used with input statements like cn. Enumerated variable will not display a name associated with the value of an enumerated data type if it's used with cout. I want you guys to study chapter 4. If you have any questions, let me know.